Ladies and gentlemen, okay, so here is the second video on IVs. So we talked about today the two formulas, okay? So I'm going to give some more problems or sample problems for those types of equations, okay? So let's do this one and let's see what we get, okay? Take off my scarf. All right, so here is a problem. It says 100 milliliters of D5, 100, sorry, it's actually 1,000 milliliters of D5 normal saline to run at 100 milliliters per hour, and the drop factor is, so you already know if you have a drop factor what you have to do, okay? The drop factor for this problem is 20, okay? So you already know what the setup is going to be. They want us to give 1,000 milliliters of D5W normal saline to run at 100 milliliters per hour. The drop factor is 20. So the formula again is milliliters, minutes times drop factor, GTT. That's the formula. So we take our 100 milliliters to be infused, divided by 60, right? 60 minutes in an hour. And our drop factor is 20. Okay, so once we do the math for this one, 1,000 milliliters, 100, my fault. 100 milliliters divided by 60 times 20, and we know that is 33 milliliters per hour. 33, oh God, drops per minute, TT per minute, okay? That's this problem. All right, let's do another one. Let's do another one. Or it doesn't crash on me. Let's try 1,000, actually, let's see, 500 milliliters. 500 milliliters of normal saline, IV, over 2 hours. Over 2 hours, drop factor is 15. Okay, so work out this one. All right, so we take this one, we have to convert, right? Because the formula is milliliters divided by minutes times the drop factor. All right, so we have the time here, but we need to convert it to minutes. So we take this times 60. So we know that that is 120, all right? So this is 120. So we take our 500 milliliters divided by 120 times the drop factor, okay? 500 divided by 120 times the drop factor, 15, and it is 62.4. Okay, so it's 62 drops per milliliter. Okay, that is this one. So let's do another one. All right. I feel like once you kind of do enough of them, it'll be a little bit easier for you. Let's see. This one is 150 milliliters, 0.9% normal saline, IV, over 1 hour, over 1 hour. And the drop factor is, the DF is 60 drops. Okay, drop factor is 60. All right, so let's work this one out. Okay, so we know that 1 hour is equivalent to 60 minutes, right? So we take our 150 divided by 60 times the drop factor, which is 60, okay? And that's going to give us 150 drops per minute. Right? It's going to give us 150 drops per minute. So that's how you work that one out. Okay, these are rather simple, honestly. The more you do them, the better you get at them, okay? So some of you may be clear on the drop factor. So let's write out another one. All right, let's say 100 milliliters of normal saline. To infuse over, let's see, 40 minutes, right? Drop factor is, let's say the drop factor is 20. Right, now you see this problem, you already know when you have this type of problem, it gives you the milliliters to be infused, okay? The time is 40 minutes and the drop factor is 20. So you already know what you have to do with this problem. It would be 100 milliliters divided by 40 times 20. We already know what we have to do. That's the setup for this one. 100 divided by 40 times 20. We know that is 50. 50 GTTS, okay? So you don't have to convert because it's already in minutes, okay, per the formula. Now, if you were to have one, let's say you were to have one where it's giving you the hour. 0. Same problem, 100 milliliters in normal saline over, let's say over 6 hours. Okay, drop factor is 20. Okay, so now with this one, it's the same scenario, right? The only thing you have to do is convert these minutes to hours. So you take your 6 times it by 60, and that gives us 360 times 60, 360. Okay, so now we have 100, which is 360 divided by 20. So let's see what that comes up to. 100 divided by 360 times 20, and that gives us 5.5, right? 0.5, nearest whole number, then that would be 6. Okay. All right, so I want you to be able to see the difference in the problems. If it gives you this type of problem with the drop factor and it's in minutes, then all you have to do is just fill in the equation. Fill in the formula. But if it gives it to you in hours and you have a drop factor, you already know that you have to convert these hours to minutes. Okay? All right, so now That's this formula. So we've already covered that formula. Okay, so now let's do another one, the milliliters divided by hours. Let's do that one. Some people are still a little confused on that one. So let's say we get 250 milliliters of D5W or D5 half, let's say, half normal saline, IV at 30 milliliters per hour. Okay, there's no drop factor in here. So you know you're not dealing with that type of problem. So you're only dealing with this one. So you would take the time to be infused, milliliters to be infused, divided by the milliliters per hour, right? Okay, 2250 divided by 30, and that gives us 8.3, the nearest whole number, 8, okay? 8 hours per milliliter, okay? Or 8 hours, rather. All right, so let's do another one. So you may see these types and you problems and you know what to do with them. All right, so let's do another one here. Let's see, this one says to lactated ringers. Oh my God, this looks terrible. Right? Lactated ringers, 500 milliliters, IV, run at 60 milliliters per hour. Okay. So this type of problem, we work it out same way. We take our 500 divided by 60, and what do we get? We come out with 8.3. Round it to the nearest whole will be 8 hours. Right? Easy, 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 easy. All right, so let's do some more. Let me find another one. Let's see. Okay. All right, so let's try this one. You may see this one, okay? So you'll know what to do. This is the one you'll probably commonly see. 500 milliliters of normal saline, IV, over 5 hours, okay? What do you have to do for this one? So this is the standard milliliters per hour divided by hours, okay? That's that formula. So we already know that we take our 500 divided by 5 hours, right? And what do we get? We know 100, right? Did I get that right? 500 divided by 5. It's 100, exactly. All right, so very simple, very simple. All right, so we already know that that is the answer. Let's see. Let me find some more. Let me see. I'm looking for more math problems for you. Let's see. Shoot. That might be it, people. I mean, I don't know. Now, there's one other problem that someone mentioned that they had a difficult time with. So I'm going to put that. Let's try this one. Here's another one. This is a new one. Okay. MD says MD ordered D5W, 1,200 milliliters in 12 hours. In 12 hours using drop factor of 15 drops per milliliter. All right, so let's solve this problem, okay? So you can look at it. We know the formula. It's milliliters, minutes, times drop factor. That's the formula. So we take our 1,200 first. We know we have to convert this, right? We have to convert those 12 hours to minutes. All right, so that would be 12 times 60, and that would give us 720 divided by 720, okay, times the drop factor, which is 15, all right? So now we can work this out. 1,200 divided by 720 times 15, and that gives us 24.9, and we round that up, and that would be 25 drops per minute, okay, for this particular problem. All right, so there is another one. Sorry, folks, I don't want to take up your time. Let's see. Just one problem. Oh, here it is. Right. I'm going to write this problem out again because some people found it to be a little complex. Oh, God, that's not it. All right, give me a second. All right, just a moment. Maybe this is it. Okay. All right, so let me write this problem on the board. As I mentioned, we want to make sure everybody understands. So here is the problem. Let me find it first. All right, so let me erase this. All right, I hope you guys are getting it or feeling a little bit more comfortable with these. Now, it said 250 milliliters of packed cells. All right, 250 milliliters of packed cells in 4 hours. Now, it asks you in part A, it says, what are the milliliters per hour? And then B is asking you the drops per milliliter, drops per minute, okay? And it's actually including the drop factor, which is 20, okay? So the first step is to find your milliliters per hour. All you have to do is divide. So that would be 250 divided by 4. That's the first step, is dividing. Okay, because it's asking us how many milliliters will we administer in an hour. Simple, that's simple math. 250 divided by 4, and that gives us 62.5. So it's going to give 62.5 drops, okay, per milliliter. All right, so 62.5, of course we have to round to the nearest whole number, and it would be 63 milliliters per hour. All right, So that's the answer to milliliters per hour. Now it's asking you, what are the drops per minute? Okay, so that requires us to set up the whole problem. So that would, now we have to convert, because now we're going to do the milliliters divided by minutes times the drop factor. There's the formula, okay? So now we take our, we have to convert the 4 hours. We have to convert those hours. So we take the 4, we times it by the 60, and it's going to give us 240. So now this is 240 minutes. So now we take our 250, which is there, all right, divided by 240 times the drop factor that's provided, and that is 20, okay? So that's 250 divided by 240 times 20, and the answer is 20.8, and we round to the nearest whole, so it's 21 drops per minute. Okay? So that's it, folks. That is it. So hopefully you can, actually, let me do one more thing before I conclude. Let's go back over those problems I did. So let's go over. I want to make sure everybody understands as well as we can. So here it said 2,500 milliliters Ringer's lactate in 12 hours. Okay, we have A, B, C, D. Okay. $10, $15, $20, and $60. $10, $15, $20, and $60. All right, so the first step, we already have the drop factor, right? So we need to convert this to minutes because that's this problem, right? Milliliters to be infused divided by the minutes times drop factor. So we already know we have to convert this. So we take our 12 hours, times it by 60, and that gives us 720. That gives us, times this by 60, and it gives us 720. So now we can do our 2,500 divided by 720 and times it by the drop factor, okay, for A, okay, we get the answer for that one. So 2,500 divided by 720 times 10, 2,500 divided by 720 times 10, and that gives us 100 and it came out to be 120 point, really? Is that what it came out to be? Doing this, yeah, I'm right. Make sure 2,500 divided by 720 times 10. Ooh, right. Check my math, y'all. So it's 34.7. Okay, we round it to the nearest whole number, and it would be 35 GTTS. All right, and we do the same thing for 15, right? 2,500 divided by 720, times 15. And we work it all the way down, okay? 2,500 divided by 720 times 15, and it came out to be 52, right? So that's pretty much it. So you do this all the way down, same thing, 2,500 divided by 720 times 20, then times 60. Okay, So that's how you work this one out. All right, so let's work one more of this and then we will finish up with this. Let's see. All right. All right, so this one was 0.45%. This is just the IV fluid, normal saline at 30 milliliters per hour. We have A, B, C, and D. I think it is 10, 15, 20, 60. All right. Once you get the setup, it's easy after that, all right? So here, anytime you have a drop factor, you know you're dealing with milliliters divided by minutes times drop factor. Okay? So we take our 30 milliliters is the amount to be infused. They don't give us a time, right? So we know that 60 minutes is an hour. So we put that there times, oh my God, times 10, the drop factor that's been given. So we take our 30 divided by 60 times 10, and that gives us 5 GT per minute. And that's the same setup for the subsequent problem. So that will be 30 divided by 60 times 15. Same thing. 30 divided by 60 times 15. And that gives us 7.5. We round it to the nearest whole number. So it'll be 8 drops per minute. Same thing for the next one. 30 divided by 60 times 20. We work it all the way down. Then we'd be 30 divided by 60 times 60. Okay? So that's it. That's it. Easy peasy. I hope this helped you a little bit more with understanding the process. So with that being said, I hope this helps, and have a good night, or maybe morning by the time you get it. Good night.